Okay, student, today I'll discuss Newton's second law of motion. And already you know there are three laws of Newton: first law, second law, third law. And first law gives definition of force, second law gives magnitude of force, and third law gives the effect of force. So Newton's second law of motion. So Newton's second law of motion. So many students does not know the exact value or calculation of the external force. So I'll also tell you that so many formulae we are using that is not correct, that is also wrong in physics as well. So first let me write its statement. So it states that when an external force acts on an object, then it is equal to rate of change of linear momentum of the object. Linear momentum of the object. So F external is equal to dp by dt, where P is linear momentum. Linear momentum. So linear momentum is defined as mass times velocity, right? So in another video lecture already I have discussed linear momentum in detail. So here I'll use linear momentum of the object is there. यानी हम लोगों को यहाँ पर सेकेंड लॉ से ये पता करना है कि हाउ वन कैन कैलकुलेट द एक्सटर्नल फोर्स, राइट? So this is the rate of change of momentum is there. So this can be written as d by dt, mass times velocity. So this is m dv by dt plus v dm by dt. So this is v dm by dt if v is constant, and this is m dv by dt when m is constant is there. That is point mass. So see, so many that is persons are writing F is equal to ma. This is wrong is there. This is wrong. Yes, if you want to write F is equal to dp by dt, right? This is the rate of change of, yes. One is varied. So one is valid only for point mass, right? So when the mass of the object is constant, then you can use this formula F is equal to ma, right? Then it is correct. But in actual, F is equal to dp by dt, right? One is valid only for point mass. Means what I'm asking you, even an object is not accelerated, then a force cannot act on it. Means if the statement is there, statement 1, if v is constant, then force must be 0. This is true or false? This is false statement. This is the false statement. Yes, it is true only when 4-point mass is there. So it is true. So in general, it is false statement. It is true. It is true only for point mass, that is when m is constant. When m is constant. Now let us take one example. Okay, when v is constant but still force is there, right? So many people, that is when you ask कि भाई velocity अगर constant है तो उस पर force लग रहा है कि नहीं लग रहा है, तो हर बच्चा बताता है भाई velocity is constant, hence acceleration is 0 and hence no force is there. That is very wrong statement, right? So let us take one example is there. If v is constant, then how the force can be calculated? So let us take one problem is there. You have, suppose, a rope. So there is a rope is there which is lying on a smooth horizontal surface. So there is a rope, right? So a uniform rope is lying on a smooth horizontal surface. The linear mass density of the rope is lambda kg per second. One of the free end is moved by an external force with constant velocity along the surface, right? So one body is pulling it along the surface with constant velocity. So with constant velocity, its free end is being pulled. Then anybody will ask you to find the force acting on it. So find the force acting on it. So in general, person will ask, no भैया ये तो कांस्टेंट वेलोसिटी से मूव कर रहा है and hence there should not be any acceleration and hence force should be 0, but it is not there. So let me complete. The question is here: external force with constant velocity acting on the surface. So find the force acting on it. So see, here momentum is not constant, P is not constant, or P is changing due to mass is there, because every time, that is, masses are added into the system and hence your momentum is not constant. So if momentum is not constant, so force is non-zero. So let us suppose that at certain instant x part is moving, right? So obviously you are applying the force along the surface. The whole chain won't start simultaneously, right? So that is one by one they will start. So suppose at a certain instant, X part is in motion. It obviously all part are moving with the same speed v. So its momentum will be mass times velocity. So lambda x times v. Because linear mass density of the rope I have taken lambda. So for unit length it is lambda. So for x part it will be lambda x v. So this is your p. So f dp by dt. So this is d by dt of lambda x v. So this is lambda v dx by dt. So this is your v. So this is your lambda v square, which is not 0. Which is not 0. So see, f versus, so this is f is constant. So f is constant at any time t. So this is constant. So lambda v square. So see, even not any part of rope is moving at t is equal to 0. Still, force is not 0 at that time is there. When t is equal to 0, force is lambda v square. So here velocity is constant. Then still force is acting because momentum is not constant. So the Newton's second law gives, if momentum is not constant, whether velocity is constant, then force acts on it. Right? So this statement which I have given you, if v is equal to constant, then the force must be 0. This is the wrong statement. Now I am going to tell to you if which statement should be there, then force should be 0, will be there. Right? So already I taught. So F externally is rate of change of linear momentum is there. So suppose if linear momentum is constant, right? So if linear momentum is constant, then force should be 0, right? Force must be 0, right? So in that statement, so if P is constant, if P is constant, then F must be 0. Must be 0. This is true statement. This is true statement is there. So in this case, we can apply net force is equal to mass times velocity, rate of change of mass times velocity is there. Let us take another example is also there. So if the linear momentum of a particle is given by 3t square plus 2t plus 1, find force at t is equal to 2 seconds. So F is equal to dp by dt. So this is 60 plus 2, and hence force at t is equal to 2, 6 into 2 plus 2, this is 14 Newton. So at every instant that we can calculate its force is there. Okay student, in the next lecture I will discuss Newton's third law of motion is there. Okay, thank you. Of course.